start recording this. To me, units are amazing. Units, whether you're doing GCSEs or A-Levels, tell you everything you need to know. But you must understand them. And you must understand the convention. All right, so some of you, someone's got this piece of work over here, managed to get to things like question D, and some of you have got down to moles. Okay, so let me submit more students. And some of you got that far, but units are so powerful. And to give you an anecdote, and I believe stories are really important, I had a very, very bright A-level physics student who turned around and said, there was a really tough question, sir. I looked at the units, it told me what to do. So I'm going to talk to you first about why I love units. Let's just get rid of that. Boom. So why I love units. I think units are absolutely amazing. So here. Why? So one unit I'm going to look at. First of all, it's just the basic idea of why I love them. So we have something called velocity, which is very different to speed, but one day I will talk about that. Velocity and speed have the same unit, which is meters per second. If we look at this, that's actually the equation. This is the formula, the equation, the formula for calculating speed. What do I mean by that? Speed equals distance. The distance you measure, you always measure in meters. This is in physics, you always measure in meters. And that backslash is the fraction line, which means divide. And the S stands for seconds, which is time. So at the top, you've got distance in meters. At the bottom, you've got time in seconds. So the unit tells you what to do. Take the distance you've got in meters and divide it by time in seconds, and you get speed or velocity, which is meters per second. And that always means, that's what it means, meters in 1 second. All right. So that's units. Love them, love them, love them. Okay, so things that are really, really important. Mass, the unit of mass. Now, I don't mind if you turn around and say, oh, the unit of mass is kilograms. Yeah, you are right. I don't mind if you then turn around and go, well, actually, the unit kilograms is weight. No, that's in normal conversation. That is not in physics talk. So in physics, mass is always kilograms. It's not grams. It's not tons. It's in kilograms. Distance is always in meters. Let's make that bigger. Time is always in seconds. Meters. Okay. Force is always in newtons. I'm not going to do too many. There's not really that many. You can mix and mingle with them. And what I mean by mix and mingle is, as I said, with speed equals distance over time. Speed equals distance over time. And we can actually work out our units. So what are the units of speed? Well, distance is measured in meters, m. Time is measured in seconds, s. So the units for speed, and I should really write speed because that looks s equals m over s, that's speed. And this is going to be seconds. So speed, the units. So you can't write on 2 lines. Well, you could do, but it's just awkward because normally we work on 1 line. So instead of writing it as a fraction, which we can do, we write it on 1 line and we write backslash meters per second. Okay, that's a simple fact. It actually tells you what to do. And I love that. I think it's absolutely awesome. And then we get into some real cool questions like what is a second? What is a meter? But that's when you're all grown up and interesting. All right. So how do we convert, especially for those who are new? Okay. I put a lovely green thing. Meters, has to be meters. In physics, length, distance, length of something has to be meters. I don't want centimeters, I don't want millimeters, I don't want kilometers. I want meters. Knowing that when we jump from kind of easy questions to harder questions, the easy questions will give you distance in meters. The harder questions will go, we're going to give you in kilometers. So this diagram is a lovely way, and actually, if you're doing a test and you draw that out, I don't mind. I actually prefer it if you're not sure. Well, how do I go from kilometers to meters? I'm going there to there. I times by 1,000. All right, cool. But what does Mr. Iqbal's really mean? And he goes, I'm going to give you in millimeters. You cannot keep your length, your distance in millimeters. You must go to meters. So you divide by 10, then you divide by 100. Again, I don't mind if you do it in that step by step, or you can just divide by 1,000. Neither of those two are any different. All right? And that's what you want to do. This is the really important thing in physics. Know what your units are. Masses is always kilograms. All right? Time, I want to talk about time. Time is really cool. It's not on here. So time is really cool. Time is always in seconds. Well, how can I be mean? Well, I could give you in minutes. Oh, that's horrible, Mr. Iqbal. I know. I know. And there's a bit where what we have in terms of kilograms and grams, those are metric units. Minutes, this doesn't work in tens or thousands, it works in 60s. So if I want to go from minutes to seconds, I would times by 60. If I want to go from hours to minutes, I would times by 60. So move all that. And that's the extent to what you'll get. We will, to be honest, I might be really cool, not cruel. I might be really cool and go, do you know what? What if I give it to you in a days? Well, from days to hours, you must times by 24. Okay? Now, if you go the other way, so you go second to minutes, divide by 60, divide by 60, and divide by 24. So I've put that one in there. Okay? So if you haven't finished last session where we did metric conversions here, there's some examples there. I've gone through everything. Take your time, show me you're working out, and answer these questions here. Okay. I also talked a bit about volume. And the reason I spoke about volume is it changed a few years ago. Well, not a few years ago, before you were born. Volume used to be, I've written it down here, right? So volume used to be litres and millilitres. We no longer use them. We use centimetre cubed and dm cubed. Okay. So you have 1,000 centimetre cubes in 1 dm cubed. To go from dm cubed to centimetre cubed, you times by 1,000. To go from cm cubed to decimetre cubed, you divide by 1,000. I wrote it as a fraction line there. I prefer fractions. I think fractions are really powerful. And surprisingly, you would not believe in a few years, you'll think, right, I want to do my A-levels. I think maths is one of, if you're wired for it, if you can sit down and do maths all day, the same type of question, I find it very relaxing, very cathartic, like knitting. Do A-level maths. It's really easy. If you are that kind of person. All right. Okay. So once you've done that, and some of you have finished that, we're going to go to moles. And the moles explanation is here. I put an explanation down here from last lesson, but just to recap, the formula for calculating moles is mass, and this is chemistry. So this is where we change slightly. Everything I talked about here was physics. Now we're doing chemistry, and this is where things change. Mass in chemistry is always grams. Always, that is the only difference. In chemistry, mass is always grams. So these are things where you've got to learn the difference. If I do physics, I'm going, here are the units of physics. These are what they're all in physics. When you do chemistry, you will always use grams. And you'll divide it by the relative formula mass. Some people like it like that. Or other people like me write MR like this. Just easier. Okay, so a little bit of unit conversion, a little bit of the difference between what is physics, units are really important in physics, and how it is different in chemistry. Okay, now, that'll be a second part. And some of you started that, and just to give you a kind of recap of that, I'm very careful about time. I'm nearly out of time. Don't like talking for more than 10 minutes. So just to give you a recap of what we did. If I turned round and I said, ooh, I have got 36 grams of water, H2O. How many moles have I got? Moles equals mass. This case, that is 36 because it's in grams already, over mR. This is water, 2 hydrogens, H plus H. Hydrogen is here, hydrogen is 1. You look at the big number at the top, 1 plus 1. Oxygen is 16. Let's add a 16 to that. I know it's 16 because I highlighted it there. 16 add 1 is 18. 36 divided by 18. The number of moles. I should really write moles because otherwise that is just confusing with mass. Moles equals 2. All right, so depending on if this is your first session, start on the unit conversion. If you are new, start on unit conversion. If you're slightly ahead, finish moles, please. All right, I'm going to stop that recording. 11 minutes. Really hit going over my 10-minute